The Cassini spacecraft was a landmark mission in the history of space exploration. A collaboration between NASA, the European Space Agency, ESA, and the Italian Space Agency, ESI, Cassini was designed to study Saturn, its rings, and its moons in unprecedented detail. It was launched on October 15, 1997, and has arrival at Saturn, July 1, 2004. The primary goals of the Cassini mission were to study Saturn's atmosphere, magnetic field, and explore the composition and structure of Saturn's moons, particularly Titan and Enceladus. Investigate the interactions between Saturn, its rings, and its magnetosphere. Key achievements of this mission was to discover liquid methane lakes on Titan, geysers on Enceladus, detailed images of Saturn's rings. The Cassini spacecraft, a joint mission by NASA, the European Space Agency, ESA, and the Italian Space Agency, ESI, was intentionally crashed into Saturn on September 15, 2017. This decision, often referred to as the grand finale, was made for several important scientific and practical reasons. 1. End of mission fuel supply. Cassini was launched on October 15, 1997, and after nearly 20 years of service, its fuel was running low. The spacecraft relied on its limited supply of hydrazine fuel to maneuver and adjust its trajectory. Once this fuel was depleted, Cassini would no longer be able to control its course or communicate with Earth. Ensuring that Cassini had a controlled and purposeful end was a critical consideration. 2. Protection of Saturn's moons. One of the primary reasons for intentionally crashing Cassini into Saturn was to protect Saturn's moons, particularly Enceladus and Titan. These moons are considered some of the most promising locations for potential extraterrestrial life within our solar system. Enceladus, for instance, has been found to have a subsurface ocean and geysers that spew water ice particles and organic molecules into space. Scientists wanted to prevent any possibility of contaminating these pristine environments with Earth microbes that might have hitched a ride on Cassini. 3. Scientific objectives. The grand finale phase provided a unique opportunity to gather valuable scientific data. During its final orbits, Cassini passed between Saturn and its innermost ring, a region never before explored. This allowed the spacecraft to collect unprecedented data on Saturn's gravity, magnetic field, and ring mass, enhancing our understanding of the planet's internal structure and the dynamics of its ring system. The final plunge also provided close-up images and data on Saturn's atmosphere. 4. Mission legacy and closure. The deliberate end of the Cassini mission was also about celebrating and concluding a highly successful mission in a controlled manner. Cassini had provided an enormous amount of scientific data, transformed our understanding of the Saturnian system, and captured breathtaking images of Saturn and its moons. Ending the mission with the grand finale ensured that Cassini's legacy was marked by a significant and scientifically valuable finale, rather than an uncontrolled and potentially destructive drift through space. 5. Maximizing scientific return. Before its final plunge, Cassini executed the grand finale phase, a series of daring orbits that took the spacecraft between Saturn and its rings. These orbits provided unique data on Saturn's gravity, magnetic field, atmosphere, and the composition of its rings. 1. Saturn's atmosphere and magnetosphere. Cassini provided detailed data on Saturn's atmospheric composition, including the discovery of large storms and the observation of the planet's polar hexagon. The mission studied Saturn's magnetic field and its interaction with the solar wind. 2. Rings of Saturn. Cassini's instruments captured high-resolution images and data about the structure and composition of Saturn's rings. The mission revealed that the rings are composed primarily of water ice, with some rocky debris and organic materials. 3. Moons of Saturn. The mission also studied other moons such as Iapetus, Dione, Rhea, and Mimas, revealing their diverse geology and histories. Titan. The Huygens probe landed on Titan on January 14, 2005, providing the first direct data from the Moon's surface. Cassini discovered methane lakes and seas on Titan and studied its thick, nitrogen-rich atmosphere. Enceladus. Cassini detected water ice plumes erupting from Enceladus's south pole, suggesting a subsurface ocean. The mission provided strong evidence of hydrothermal activity on Enceladus, making it one of the prime candidates for the search for extraterrestrial life. 4. Insights into planetary rings. Cassini's instruments analyzed the rings' composition, revealing that they are made primarily of water ice with traces of rocky material. The mission provided detailed information about the rings' particle size distribution and density waves. Data on the rings' age and the processes that shape them have helped scientists understand how rings form and evolve, offering clues about similar processes around other planets and exoplanets. 5. The final orbit and plunge. Starting in April 2017, Cassini entered a series of 22 orbits, each taking it between Saturn and its innermost ring. These close passes allowed for unprecedented data collection on Saturn's internal structure, magnetic field, and ring particles. On September 15, 2017, Cassini made its final descent into Saturn's atmosphere. As it entered the atmosphere, it transmitted data back to Earth until the signal was lost, marking the end of the mission. The decision to crash the Cassini spacecraft into Saturn was driven by a combination of practical limitations, scientific goals, and ethical considerations. By ensuring a controlled end to the mission, NASA protected the integrity of potential habitats on Saturn's moons while maximizing the scientific return from the spacecraft's final orbits. Cassini's grand finale not only concluded an incredibly successful mission but also set a precedent for the responsible and thoughtful end-of-life management of interplanetary missions.